Okay, so excuse me, this is a walkthrough of a rotational kinetics problem. Let's imagine that we have an object that's connected to the wall by a hinge. And so let's say it's this board, and we have a force applied here of 10 newtons. And in addition to that, the board has a mass of 5 kilograms. And it has a length of 1 meter. And a thickness of 0.1 meters. And we want to calculate the angular acceleration of this board. Well, we're going to use rotational Newton's second law. So for a first step, you can do things in a few different orders, but you might as well calculate the mass moment of inertia. So pause the video for a second and see if you can calculate the mass moment of inertia, capital I, for this board. Okay, well, in order to do that, you have to identify what type of connection, where the hinge is connected to the board. It is on the far end of the 1 meter length, and it's in the middle of the 0.1 meter thickness. So we're going to use the formula 1/3 times the mass times the length squared plus 1/12 times the mass times the thickness squared. And we get a moment of inertia of 1.67. And you can figure out the units of this just from how you do the calculation. So kilogram meter squared is what you get. Okay. Well, that's the mass moment of inertia. Now we need to figure out what the total moment, the total net moment is on this body. So start by drawing a free body diagram of the board. So pause the video and see if you can draw a free body diagram. Okay, well, there's a weight force that acts always at the exact middle of the object. So that's 5 times 9.81, so 49.05. There's also, we're told that there's a 10 Newton force acting here. We don't know what's causing that force, we just know that it's applied. And then the last thing is, at the hinge, there's an unknown force. You should put this in your free body diagram, but if you don't, it doesn't affect the moment calculations. But I'm going to write that as there's some x component and some y component, but we don't know what those are. Okay. This is a complete free body diagram. Now you have to figure out the moments produced by all these forces about that hinge. So take a minute and see if you can calculate those. Okay, so first of all, what's the moment produced by Rx and Ry? Since both of these forces act through the hinge, the distance d is 0, and so these always produce 0 moment. The forces that are provided by the hinge always produce 0 moment. Okay, now what about the weight force? Okay, well, this is going to be plus or minus the force times the distance from the line of action of that force to the hinge. So that distance is this. You can see that it's only half of the length of the beam. So since the whole beam has a length of 1, this is just going to be 0.5. And now the final thing you have to do is figure out if this thing was free to move around this hinge and the only force acting was this weight force, would it make it rotate clockwise or counterclockwise? So think of tapping this object at this point straight down. It would make this object, the board, rotate clockwise around that point, around that hinge. And clockwise is always negative. So this comes out to be a moment of negative 24.525. And the units are newtons times meters. There's only one more force we have to deal with. That's the 10 Newton force. So that's going to be plus or minus the magnitude of the force times the distance from the line of action of this force to the hinge. You can see this time it's the full length of 1 meter. That's the distance from that blue line of action to the hinge. Whoops, not 10, just 1 meter. And imagine only this force acting and the object free to rotate around that hinge. It would make it again rotate clockwise. So this is going to be negative again. And now that we have the moments produced by all of these forces, we can go to the rotational version of Newton's second law. So add up all these moments. So we have 0, minus 24.525, plus 10 is equal to the mass moment of inertia times the angular acceleration. And so we have, this was a negative 10, so that should be minus. And so we have negative 34.525 is equal to 1.67 alpha. Divide both sides by 1.67. And you get that alpha is equal to negative 20.67 radians per second squared. Since that's negative, you know that this board is going to rotate clockwise, which makes sense if you think about applying, if this thing being connected to this hinge and the only forces are the weight force and this force here, it's going to make the right end rotate down, which is a clockwise rotation.